Hello everyone, welcome to my channel Chemistry is Fun. Today we will deal in detail equivalent weight. So I have today chosen the topic concept of equivalent weight. It will be helpful for NEET and JEE Mains 2024. Now first of all, we will see theoretically and also some of the examples related to it so that the concept will be very clear. Now, as per the definition for an equivalent weight will be given in a different way for different substances, like whether it is a salt or a base or an acid. The sample we have taken, when that differs, the definition of equivalent weight will also differ with that particular substance. It is different for different substances. Now, we'll see one by one. First is equivalent weight of an element. Now for an element, equivalent weight will be a number which will denote the number of parts by weight of that element which is required to combine with or displace 8 parts by weight of oxygen or 1.008 parts by weight of hydrogen or 35.5 parts by weight of chlorine. Means it can displace this much amounts of some certain elements like oxygen, hydrogen or chlorine. How much it can displace, that has been specified. For oxygen it is 8 parts, for hydrogen 1.008 parts, for chlorine it is 35.5 parts. Now for a particular element, the atomic weight of that element can be calculated if we know the valency. Now atomic weight of the element divided by valency of the element gives the equivalent weight. Atomic weight divided by valency. So you can say, as in case of sodium, atomic weight divided by valency, that becomes 23 by 1. So equivalent weight of sodium is 23. We know valency for sodium is 1. So it is 23 by 1, that is 23. Now in case of oxygen, for oxygen valency is 2, atomic weight is 16. So equivalent weight again is atomic weight by valency, that is 16 by 2, we get 8. For the ions, equivalent weight will be equal to molecular weight of that ion divided by valency. For the ions, an ion also can have the equivalent weight. It is equal to molecular weight divided by its valency. One example we will see, students. Sulfate ion, SO4 2 minus sulfate. It is having 2 negative charge. So its equivalent weight will be equal to, we will take the molecular weight. For sulfate, molecular weight is 96 divided by its valency. How many charge it is having? 2 charge. Minus 2, so divided by 2, that equal to 48. So it is, for sulfate it is 48. Next, for an acid, we come to equivalent weight of acid. The number of hydrogen atoms in a molecule of the acid which can be displaced by any metal is called the basicity of the acid. For example, in case of HCl, when HCl reacts with a base like NaOH, the hydrogen of HCl will get replaced by sodium. So one hydrogen it is having, and that can be replaced by a sodium. So for any acid, the number of hydrogen atoms in a molecule of that acid which can be displaced by metal ion is known as the basicity of the acid. So once we see calculate the basicity, we can find out the equivalent weight. So for an acid, the equivalent weight of the acid equal to molecular weight of an acid divided by basicity of the acid. And what is basicity? The number of hydrogen atoms which can be displaced by metal ion. So we can calculate equivalent weight for acid also. Next comes base, equivalent weight of base. Now areneous bases contain hydroxyl groups, as in case of NaOH, there is one OH group. Now the number of hydroxyl groups which are present in a molecule of the base is known as the acidity of the base. How many hydroxyl groups can be replaced, means how many hydroxyl groups are present in a molecule of the base, that we call as acidity of that base. Then equivalent weight of the base will be equal to molecular weight or formula weight of the base. We first take the molecular weight of the base and divide it by acidity of the base. We will get the equivalent weight. Next, for salts, equivalent weight of salts. We know salts are neutral. In the salts there will be cations and anions. Salts contain both cations and anions, as in case of sodium chloride, NaCl, Na plus cation, Cl minus negative ion anion. Overall, the total charge is neutralized, so salts are neutral. Overall positive charge should be equal to overall negative charge in any salt. So equivalent weight of salt can be taken as molecular weight of the salt divided by overall number of positive charges on all the cations in the salt molecule, and that will be equal to molecular weight of the salt divided by overall number of negative charges on all the anions in the salt molecule. So either of these we can take, because total charges are same, so charges on cations will be equal to charges on the negative ion, that is anion. So total negative charges or total positive charges, whatever we want we can take, both are same in number. So from here we can calculate equivalent weight of sodium carbonate, Na2CO3. Na2CO3. Now here we have to take molecular weight of Na2CO3 divided by overall positive charges, and that will be equal to molecular weight of Na2CO3 divided by overall negative charges. Both are same, so both will be equal. So for Na2CO3, two sodium atoms, so 2 into 23 plus 1 carbon atom, so 12, 3 oxygen atoms, so 3 into 16, divided by, for Na2CO3, see two things are there. Cations, if you see, there are two cations, Na plus, 2 Na plus. Each sodium ion has single positive charge, but there are two sodium ions, so 2 positive charge. If we take the carbonate ion is single in number, but it carries 2 negative charge. So overall charge due to the anion carbonate is also 2 negative. So either of that we can take, so we have to divide by 2. So 2 into 23 for sodium plus 12 for carbon plus 3 into 16 plus oxygen, which is 3 in number. So when we add up, we get 106 divided by 2, that is 53. Next is equivalent weight of oxidizing and reducing agents. Now whenever there is a stoichiometric equation, when the number of electrons transferred from 1 mole of the reductant to 1 mole of oxidant is n. So a reductant should give the electrons are transferred from 1 mole of reductant to 1 mole of oxidant, and if that is equal to n, then equivalent weight will be equal to molecular weight of the reductant divided by n, that is number of electrons transferred. Or we can say it is molecular weight of the oxidant divided by n. Now see, we take one example here, FeSO4. FeSO4 is a reducing agent. Now the question arises, why it is a reducing agent? Because it can give away electrons. So it can reduce some other species, and itself it will get oxidized because it is giving away electrons. It itself will be oxidized, but it can reduce some other species. So when FeSO4, it is a reducing agent, it is oxidized to Fe2SO4 3. Why oxidized? Because in FeSO4 iron is in Fe2 plus. In Fe2SO4 3 iron is in 3 plus state, so it is oxidized. You see, Fe2 plus gets converted to Fe3 plus by losing electron. And here, as per this equation, you see 1 mole of Fe2 plus ions can lose 1 mole of electrons. 1 Fe2 plus ion can lose 1 electron. So 1 mole of Fe2 plus ions can lose 1 mole of electrons. Next is equivalent weight. How to do? Molecular weight of ferrous ion divided by number of electrons involved. We can see that there is only 1 electron involved, because when Fe2 plus converts to Fe3 plus, only single electron given out. So number of electrons involved is 1. On top we have to write the molecular weight of ferrous ion, that is 55.84. So it is 55.84 by 1. We get 55.84. I hope today all could understand whatever I taught. You could understand my topic. Thanks for watching. Please subscribe to my channel. Thanks for watching. Thank you all.